So welcome to 2015 question A-1. Okay, the 3D graphic below shows a display box, okay, for chocolate eggs, which is based on a truncated prism, so prism that's been cut. The drawing below shows the incomplete projection or pictorial and orthographic projection of a square-based prism which has been cut by oblique plane VTH. Okay, so we have the partial projections there of our truncated prism, and VTH there which has cut it, and here's our VTH in plan elevation and our partially completed views. So they want us in part A to complete the orthographic projection on the right, so the elevation plan of our cut prism. Now with this one it's nice because they've actually kind of give us a hint as to how they want us to solve it, because there are two methods. One, we could take an auxiliary looking along HT, so we could see HT at an angle there, or sorry, we could see the oblique plane at an angle and project up our prism and find where it has been cut and bring it back, okay, or find the heights that it's cut at and project and step them off here. But you can see here they're using the horizontal section method. So the horizontal section cut through our prism creates this line. Okay, so where two planes intersect, they create a line. Okay, and because it's a horizontal section, a horizontal cut, it's going to be parallel to my HT because that's resting on a horizontal plane. Okay, you can see here this line in particular. Let's look at it. It's parallel to HT. Okay, because it's representing a horizontal cut, and in there in elevation we can see it's a horizontal line. So we're going to follow the same steps they've done rather than taking the auxiliary. Let me just see, is this a nice angle? Yeah, nice 6-degree angle. So I'm going to project up my edge here, parallel to HT, draw that vertically until I hit my VT, and it's a horizontal line then, so I can project it back over a bit further onto that blue edge. So that is that point in elevation. Okay, I'll repeat the same step then for that bottom edge, vertically up, and it's a horizontal cut, so there it is. Okay, so now I can draw in my cut surface. That's my elevation completed, and in my plan we can see it's cutting out through the whole object, so we're still, when we look down, we're still going to see this surface. Okay, so that will stay as appear as it's square when we look down on plan still. Okay, so now they want us to complete the pictorial projection of the cut prism. So they want us to essentially, for those 2 points or edges that we found, they want us to show the same steps here in our pictorial. So, like I said, it's a horizontal cut, so parallel to HT, a horizontal section, sorry, that we're taking. Or creating a horizontal plane, I should be saying, from HT, which will appear in the plan view as a horizontal line. So running now like that. Okay, we'll do the same here for my front edge. Okay, then it runs vertically, so parallel to HT, and it runs vertically on in the elevation, which is on the vertical plane. So here's our vertical plane, and we're going to run vertically, so parallel to those edges until we hit our HT or VT, and then horizontal line again, horizontal line here, so back parallel to our HT to that edge and to that edge. Okay, and that will allow us to draw our cut surface. Put in the edges there. Okay, so I'll just put in those arrows just to show you that's what I've done there, and then back. So that was kind of easy enough because we're mimicking what is essentially being given to us. Okay, so that's part A and B completed. Part C, on the orthographic projection on the right, so here we have it, determine the true length of the shorter diagonal on the cut surface. Okay, so the shorter diagonal, right? Looking at our object, we need to determine first of all which is the shorter one. Is it going to be running this way? Is it going to be running this way? Okay, and just through kind of using your kind of head, I suppose, we can determine that this one is probably going to be the shorter diagonal. Okay, rather than that one. Okay, so this is my shorter diagonal. I'll show it in elevation. Just for the sake of it, we're not asked, but I'll show it in 3D view there. And I'll highlight that. So that's the line we're working with, and they want us to find the true length of that diagonal. So a number of ways we can do it. We could take an auxiliary, so go parallel to my true length, so look perpendicular to it. I could draw my XY line, or X1, Y1, and because I'm projecting from a plan, it'll be an auxiliary elevation. I can take my heights from my elevation. So that's one method. Okay, and then another method is we can rotate that line around so that we're looking perpendicular to it in elevation. Okay, looking at the marking scheme, I can see that they're doing the rotation, so I'll just follow that and match it up. So here's my line. I'm going to rotate it around like so until I'm looking perpendicular to it. Okay, so I've rotated that. And that is the new position of that line. Okay. We then want to find that line in elevation when we're looking perpendicular to it. So project up. And this point we'll call this 1 and this 2. So that's the new position of 2. 1 has stayed in that same position. Okay, it hasn't moved, so 1 is still here. 2 then, the height doesn't change, it is rotated essentially around like that. So that height will stay the same, project out. So here is the new position of 2. I'll highlight that. I'll just show the projections there as well. So that's my true length. Okay, so that's 2015 question A1.